Hi, my name is Yoav Weiss, and I'm here to talk about responsive images. Yeah. Okay, so I've been with the Responsive Images community group for the last 2 years, working on native browser prototyping and implementation. I've been contributing to Blink as well as WebKit, more Blink, but I did the source set implementation in Blink and currently working on the picture implementation. And I also been working on front-end optimization service for a while. So what is responsive images? Basically, it's the problem of efficiently loading properly dimensioned images to fit the page's design. That kind of captures all the use cases, but as we will see, there are multiples of them. The problem started out as a quality issue for retina images and such. The solution web developers came up with to that is a rather simple one, just sending out all the largest images possible to the users and letting the browsers resize them. At the beginning, that was the state of the art, but it turned out to be a suboptimal solution. The problem that we came up with is bloat. Responsive websites became a synonym to bloated websites because most of the websites simply served the same resources to all kinds of viewports and all kinds of devices. And these resources were mainly images. And a ton of that can be saved. I wrote a utility that basically downloads a web page and estimates how much can be shaved off if the images are adapted to their actual display dimensions. And the answer is, for most responsive websites, a lot. So from a quality issue, we came to a data plan abuse issue and the user's time abuse issue. And again, responsive websites were known to be slow, which is a problem. Web developers gathered up and started looking for a solution, demanding for some kind of a native resolution to this problem, mainly because all JavaScript-based approaches were hurting performance one way or another. A lot of mailing lists, a lot of mails have been sent, a lot of proposals have been suggested, and eventually the Responsive Images community group was born. Then, a few months later, the community group came out with a picture proposal. And on the other hand, on the WhatWG, there was the source set spec that went into the HTML spec. And for a short while, it was a picture versus source set kind of situation. So which proposal will be the winning one? But it soon we soon realized that picture and source set are handling different use cases, and both have their place within the larger proposal. The thing is that the original picture proposal got a lot of resistance from browser vendors, and I'm today convinced that that was the right thing to do, because the original proposal was way too complex and basically reinvented the image tag. So it had a lot of duplicate functionality with the existing image tag. That resistance led to, let's say, a lot of stagnation around the responsive images issue. And then after a meetup and some talks, Tab Atkins here, and John Meller. A lot of Tab Atkins, John Meller, and a lot of wine came up with the source end proposal, which wasn't accepted by some browser vendors, but it had some major innovations to handle some of the use cases, and it kickstarted the responsive images debate that kind of winded down. And short while after that, on the WebWG IRC, Simon Peters and myself started discussing a possible syntax solution, and then realized that we can just flip it a little bit, and it will look very much like the original picture proposal, even though the internals are significantly different. And nowadays, we're working together, the Responsive Images Community Group, and as well Tab and Simon and John Schwinnick from Mozilla. We're working together on the spec and the implementations, and things are peachy. So, what is this new proposal? No, the new spec. The source X part is very much what the original WebWG proposal was. Basically, it handles the retina images use case. So it loads high-resolution images only on high-resolution devices. And the syntax itself is basically just provide a grocery list of image resources to the browser and let it pick from them according to its DPR. So this is how the syntax works when it's inside picture, but it can also be a part of just the image element with the source attribute. That part is currently implemented and shipped since Chrome 34, and it's working pretty well, and people are using it, started using it. I don't have usage data, but people are using it. So moving on to the next part, the picture part, the part that requires multiple elements. The use case for that, the main use case for that is art direction. So basically showing different crops or different aspects of a single image on different viewports. So it will allow us to allow a web developer to show more context of an image when there's room for it, but focus on the subject when there isn't, or in some cases show different angles of, for example, a product. They can show different angles depending on the viewport dimensions. Basically, adapting the image to the layout that the end user will see on the device that is accessing the web page on. And the second use case is it provides us with a MIME type fallback. So basically, web developers can define different resources, each one with its own type attribute, and the browser will pick the first resource that it encounters that it can actually handle, that it can actually read. The reason that's important is because whether we like it or not, the web today has become fragmented when it comes to image formats. And there's WebP for Blink, there is JPEG XR for IE, and JPEG 2000 for Apple products. So this basically allows images to be first-class citizens in a way when it comes to MIME type fallback. much like fonts and videos have always been. It doesn't. Web developers can still use server-side solutions for that, but this can also enable them to use client-side ones. So the syntax of picture is basically it comprised of a picture parent element, which doesn't do much besides being a container. It's what Tab likes to call a magical span. And its children are source elements, each one with its media attribute. So the browser can go over the source elements one by one and pick the first one with a matching media attribute and a matching type. And then it looks into the source set attribute and just picks the resource that fits whatever DPR or that it needs to fit. One big difference with the original picture proposal is that the image, the fallback image here, is not optional. If it's not there, nothing is displayed. And the reason is that image is driving the selection. Basically, image is looking at its parents, then going down from there to their children, looking at its parent to the children, and go over the source elements until it encounters itself. So the image is still doing all the hard work, the work of displaying the image. So we're not duplicating functionality, and we don't have to duplicate the thousands of tests that the thousands of layout tests that are testing image. This is one of the good things about this renewed proposal. And so moving on to the third and the most exciting part, in my opinion, is the sizes attribute and the W descriptor. Basically, it enables web developers to provide hints to the browser regarding what would be the image dimensions for certain breakpoints, for certain responsive breakpoints. And the use case here is variable width images. So in this case, the web developer can let the browser know so that the browser won't have to download the CSS in order to know that for small viewports, the image will take 100% width of the viewport, and so as the example shows, you can basically have multiple sized images on different viewports without guessing that one will be smaller than the other. So in this example, for very small viewports, the images are actually larger than on mid-sized viewports, but the syntax can account to that. The syntax is slightly more complex than what we've seen earlier, but it takes a little bit getting used to, but once you get it, it's working very well. So basically, the sizes attribute is a list of media conditions, a subset of media queries, and CSS length. The media queries is stating the breakpoint to which the length is applied to. So in this example, for width that is smaller than 30 EMs, the image will take 100% of the viewport. After that, it's 50%. And anything beyond that, it's a third minus 100 pixels. We can use calcs as a replacement for the static length. And basically, it provides the web developer with the power to hint the browser on the dimension of the image. Then source set is it's the same grocery list that we had earlier with DPRs. Here, the grocery list is composed of image dimensions. So we tell the browser that each one of the images is of a certain width. And the browser can do the math itself and decide that if the viewport is of that size and I need a half of that, this is the best image that fits my needs. And also the spec is flexible enough to let the browser override, or not override, but decide on which, for example, if the bandwidth conditions are not great, the browser can pick the smallest image and compromise quality for the sake of speed, possibly based on user preference, etc. This is not part of the implementation today, but it's something that can be added later on. And basically what the browser does is it takes the size, then divides it by the width, and comes up with a DPR for each one of the images, and picks the best DPR that fits its screen. And the same, exactly the same syntax can be applied to the image tag. This part is currently implemented, not yet shipped. I'm hoping to try to ship it for Chrome 37 once we're sure that the spec is stable enough and things are not going to change, or we estimate that things are not going to change. When it comes to browser support, so in Blink, I already discussed it. Source set has shipped. Sizes and the W descriptors are implemented, and I'm currently halfway through the work on the picture element parts. And it's also worthwhile to state that I was able to, I didn't say it earlier, but I'm an independent developer, and I was able to support this, was able to finance my work on this, or part of it, with an Indiegogo campaign that I've ran a month back. It ended 2 weeks ago, and so I'm very excited about that. So yeah. Firefox, John Schoenig is currently working on it. It's currently in review. According to him, it's likely to hit dev version soon. I'm not sure what the definition of soon is, but one of the one of the upcoming releases. IE are showing interest. Mainly, they're showing up on IRC. They're asking good questions. They're not. We don't have comments beyond that, beyond under consideration. There is no official word, but it looks like it's actually under consideration. And as for WebKit, they have implemented the source set X descriptor part a few months back. I was involved in that implementation as well. It hasn't yet shipped in any in Safari 7.1. It hasn't yet shipped, so I'm not sure what's the status on that. And they're willing to accept patches for everything else behind the compile flag. So they're as enthusiastic as they can be. So just a short overview of the classes and the work that that was added. So that if you would bump into that when you're going through the code, you'll know who to blame. Basically, it's part of the picture and sizes evaluation. In order for that to happen at preloader time, a lot of stuff I had to re-implement a lot of stuff related to media query evaluation in order for that to be thread safe and off main thread safe. Since the Bison parser and a lot of the CSS classes aren't, so I've had no alternative to reuse the current infrastructure. So I started out by taking Eric's tokenizer that he did during Christmas, the Christmas vacation. Yeah, awesome. So so basically I adapted it to the needs, to my needs, and for media query tokenization. So thrown out the CSS parts that weren't needed and filled in the missing parts that I did need. And then built a media query parser on top of that. It's currently turned on for everything that's off main thread. So it's turned on for all media queries that happen on the preload scanner. Media attributes for external style sheets mainly. And I hope to turn it on for all media query evaluation soon, because I believe it has better spec compliance, and it'd be easier to add stuff on it, especially all the new stuff that rely on the CSS syntax spec. So calc support and perhaps media query level 4. Media values is a class that I added as an abstraction layer to the media query evaluator. Basically, it enables a cached variant, so you can send out, basically initialize the media query evaluator and give it cached values if you know that you're going to throw out the media query evaluator pretty soon. Or if you're using it off main thread, in that case, all you have is cached values. And it also has a dynamic variant which references a local frame and keeps you can have the values fresh, and that's good for long-lived media query evaluators where you resize the browser. Browser resizes, etc. All environmental changes are reflected inside the media query evaluator. And one of the good surprises is that I was able to rid the media query evaluator from render style dependency, and was able to get rid of style recalc, doing that accidentally, but it's a good surprise. And it also implements a thread-safe CSS length computation. And then once I got past the infrastructure stuff, I was able to build a sizes attribute parser on top of the tokenizer, and it uses the media query parser as a component, and a calc parser that also uses the tokenizer, and basically getting rid of the parentheses using turning the expression into a reverse Polish notation, and then evaluates that and gets out the length. And one of the earliest additions was the HTMLSrcsetParser. That's a pretty simple standalone parser for the source set syntax. It's used from the HTML image element and the preload scanner. And basically it parses the sources attribute, converts the W descriptors to DPR, and then picks the best candidate. And one important aspect to note is that the source set values impact intrinsic sizing. So for X descriptors, if a web developer is lying to the browser and saying that a certain image is more X than it really is, then the image will, unless the width or the height are stated explicitly, the image will be displayed smaller. Same is true for W descriptors. And last but not least, there's the stable state image loading changes that landed today that Christian Basinger is responsible for. And that enables us to avoid double downloads when with the picture selection algorithm. So the image, when the image is loading the resource, it actually knows who its parent is, unlike earlier on. And it also enables us to set the JavaScript attributes on the set attributes using JavaScript on the image element, regardless of order. Because earlier on, if you'd set source set, and then if you'd set SRC and then set source set, if you had a 2x display, the browser would send out 2 requests. Now that is fixed, so that's awesome. And yeah. And moving on to possible future improvements. Some of them are reasonable, some of them are more science fiction-y. The first casualty of in the proposals war is client hints. It's basically a complementary solution that's based on a content negotiation solution. So the client is sending out hints regarding a DPR regarding resource width to the server, and the server is sending an appropriate resource, stating the DPR of the resource. Basically, it enables to use the same client-side mechanisms for our direction and sizes, but avoids the grocery list on the client side and enables to do that on the server side. There is a very preliminary implementation in Blink, but I think that it wasn't yet kicked out. The problem is that other browsers are not very happy with such a solution since they object to content negotiation in principle and claim that it's a fingerprinting vector, which is, yeah. So the future for that proposal doesn't look bright, even though I personally believe that it could be a good complement. The original was first proposed by Ilya Grigorik, and yeah, all the rest I already said. Another thing I played around with, this was never a serious proposal, but I just prototyped during the time when a markup solution was not, I mean, we didn't know what the markup solution would be, so I played around a little bit with the idea of a responsive image format or responsive image container. It's based on basically an MP4 container that contains multiple images that are either WebP or JPEG XR. And these multiple images are, I mean, the first image is a full image, a full thumbnail image, and consecutive images are just diffs of the expanded thumbnail superposed with the actual image that would be appropriate for this size. So I'll just basically a layer per resolution, and it handles resolution switching, so DPR and variable width images, as well as our direction, or at least some forms of our direction, everything that's crop. I'll just show a bunch of examples regarding that. So for resolution switching, if this is the full image, we can split it into a thumbnail, followed by an slightly larger diff. We can't really see the gray. I mean, the gray image is a diff image of the previous thumbnail stretched, and then versus the crop, the resized image in that dimensions, in these dimensions, and a slightly larger one brings us to the original file dimensions, and it's pretty much the file size in bytes is also very similar. So we don't really pay any significant penalty in terms of byte size here. The main, yeah, I'll just go over our direction. If we have this image of Mr. Obama, that for some reason all our direction examples are somehow related to Obama. I think it's because Jason Grigsby coined the term. He worked on his campaign for a while. I'm not sure, but all examples of art direction are somehow related to Obama. This image is split into a thumbnail or just a crop focusing on the subject. Then for the larger resolution, you can see basically it's a diff again that complements the thumbnail with the larger quality and with more context, and the following one after that. So the advantages of this approach is that we can leave markup untouched. There is no markup work. Everything is done in the image. And there is a single file per image, so that's easier to maintain for web developers. And if we have post-download dimension changes, so if the user changes orientation, for example, and we need a different image, we can just download the diff. We don't need to re-download the information that we already downloaded in the first place. The disadvantages of this approach is basically that it's hard and complicated to get image formats out there with all the ecosystem and tools that enable people to use them. The coding performance is, I didn't really look into that, but it's a concern because we have to do multiple resizes per layer. So for each layer, we have to resize the thumbnail, glue in the next quality layer, and then do that again. So basically, the more layers you have, the more time it would take for you to decode such a format. And the main concern is that fetching mechanisms are not really there unless HTTP2 is involved. So for this would have to be something that's HTTP2 only, or there would be a significant penalty when it comes to network performance, because you'd have to download at the very least, you'd have to download the initial header, the image header, in order to know what byte range you want to download for the resolution that you need. So there are multiple RTTs here. It can be mitigated with HTTP2, but otherwise there is a penalty, there is a trade-off. So this is not really something I'm actively working on, or anyone is actively working on at the moment. So this is in the dream territory, but I thought I'd show you. And since we have some time, I'd like to show something that an experiment by John Meller, but that, well, we've talked about together at EdgeConf a few months back. Basically, progressive image download across the website. So this is not specifically related to responsive images. This is just any kind of image download, but it makes a few good points regarding image download in general. So basically, again, HTTP2 will enable us to start downloading multiple ranges of all the images on the site at once, versus the current approach where we download one or seven, let's say 4 to 6 images in parallel, but we download only a small set of images, and we display them as we download them. So basically, if you download all the website's images at once, and the website's images are of a progressive format, so progressive JPEG is the best example in current formats. Basically, once you get to, we can't really see that here, but once you get to 20 or 30% of the downloads of the image data, you get a pretty good user experience already. So from there on, it's only quality improvement, but you have all the website's images, you know what's going on. Whereas in the competing example, if you can see that on the left-hand side, this is sequential image loading. On the right-hand side, it's parallel one. And you can see that on the left-hand side, only 1 or 2 images have finished loading, whereas on the right-hand side, almost all of them, all the images that are in the initial viewport have finished loading. And basically, around 30% there, you can, or around 40%, you can't really tell the difference. The browser can continue loading the rest of the image data for quality, but you can basically provide significantly better user experience just by fetching the images in a smarter way. But again, this is not really responsive images. This is just a wild experiment that John did a while back. Just responsive images are coming. I hope that in the, either 37 or 38 we'll be able to ship. And thank you very much. So, any questions?
Can you talk a little bit about how your crowdsourced development works? Like, how did you advertise it, and how did people find you? Who was interested? Like, who were the customers?
I basically let off. Oh, right. So, how did the crowdfunding of the picture worked? How did I advertise it, and who were the people putting in money? Basically, one of the advantages of being part of the Responsive Images community group is that there are a lot of high-profile Twitter people there that have a large number of followers that basically all advertising work through Twitter. And since the Responsive Images community group is, I mean, there are over 300 members that actually went through the pain of registering through the. So that's a nice number, and there are about, I think, 3,000 followers to the responsive to the community group Twitter account. So basically, all advertising was through there. Matt Marquis did all the PR stuff, and he did an excellent job at it. And the people supporting there was first of all Google. I think it's the DevRel team, but I'm not sure who. It all gave money. Opera DevRel gave money as well. Some web development agencies, and a lot of independent developers that some of them were involved all along and some not so, but were following up on how things are going. And so, yeah, that was part of the reason why I decided to do this crowdsourcing thing, was to prove that when people are interested, they're willing to put their money where their mouth is. And that worked out pretty well. So I'm happy with that. Any more questions?
Yes, so I was wondering if there's any way of getting feedback on the server side for the quality of the source set matches that are being done on the client side.
Okay, so the question is there a way to get feedback on the server side regarding the quality of the source set matches on the client side? You can get, using RUM techniques, you can get which resource was picked. That's a recent addition to the API, current SRC attribute that lets the web developer know and report what was picked.
But it was the best fit, but it was still a poor DPR match. Maybe the web developer would like to collect that feedback.
How would you define a poor DPR match?
Well, for example, the highest resolution provided was not high enough.
Okay. So basically, you could do that with, there is no reporting API, but you could, as a web developer, you could do that by checking out which resource was picked, looking at its DPR, and checking out the DPR of the machine and see that there is some difference there. There is no native API that does directly that, but you can probably write a pretty simple library that does. Okay. Does that understand? Okay. Yes.
All of the features supported by source set sizes and pictures are proposed in CSS, and did you implement anything in CSS and the external styles? Did you do anything to support that, or will you?
Yeah, the responsive images movement was mainly focused on content images, not on CSS images. Yeah, so other than that, there's source set and there's media queries, but
so the closest thing we have right now is the WebKit image set function, which does the basic source set stuff, just URLs and the X factor. And that's specified over in the images spec, so other browsers should hopefully do that eventually. The basic media stuff can just be done by using that plus media queries. The only thing that can't be done in CSS right now is the sizes stuff for variable sized images. And I expect to at some point augment the image set function with some of that functionality. In fact, there's a CSS working group face-to-face next week that I'll be attending that will be discussing that exact topic. What exactly we want to do to handle responsive images in CSS in a way that matches up with HTML, so authors just have to learn one thing and can apply that knowledge across everywhere.
Awesome. Any other questions? Okay, so thanks.